We will continue our training from where we left off. We're still dealing with structured query language. We have gone through select, distinct, count, update, alter, commit, create. Today we'll start from constraints. Constraints.
It's a tire.
Yes, ma'am. The domain. Oh. This is my server name. When we start this refresh from count. Count. We said count is used to count the row in a table. So we have a table called Providence. We just described it right here. Select count. What do I want to count? I want to count everything. From where? From the table where we are trying to count. We have 38 rows. Count. Can we count the country? We have 38 rows in the column country. It is used to count the row in a table. Delete. Now this is where we have to pay attention very, very well. We said delete is used to remove a record from a table. It is not used to delete the table in of itself. It removes the record from the table. To practicalize this, I will save this stuff right here. I still have my table called Providence. And I still have the data of the table in the table. We'll now execute that command, delete. Delete Providence. You will notice that it says 38 rows deleted. The table still exists in the database. However, there is no row inside the table. No rows inside the table. Our next command that we are going to refresh on is called drop. Now this is used in dropping an index, table, even the database. Anything you create can be dropped. Anything created can be dropped. We have a table called Providence here. Remember we deleted the row a few minutes ago. We have rolled it back. So we still have we have data inside the table now. So we have 38 rows. So we will now say drop table Providence. table dropped. When the table is dropped, the table as well as the content is gone. Let's describe that providence. Object providence does not exist. The next command we are going to learn is rename. Rename. It is used to rename a table or a column for that matter. But in this case, a table. From one name to another. We have a table name that is called Providence. Now, let's rename that table. Rename Providence to Divine. If I describe Providence, it will tell me it doesn't exist. Why? Because the table has been renamed. Describe Divine on the other hand, I will get a result. Why? Because it has been renamed to Providence. Let's rename it back. Describe the Providence that we did few seconds ago. It does not exist no more. Why? Because it has been renamed. Rename is used in renaming a table or column or whatever the case may be. Renaming an object, basically. The next command that we want to refresh ourselves on is truncate. The next command we are going to learn is truncate. Now, there's a reason why I'm putting delete, drop, truncate on a notepad. They are used in removing stuff, but we need to know the difference. Now, the first one that is very, very easy to identify, we are going to delete it, is drop. That one is used to delete a table, at least in this context. We are deleting the table. So that one is very, very easy. That brings us to truncate and delete. What do they do? Truncate table Providence. Table truncated. But the table still exists. So what did truncate do? Truncate removed all the rows in the table. Similar to what delete did. Delete deletes the row in the table. Truncate deletes the row in the table. So if the two are the same, what makes them unique? One is a DML, the other is a DDL. We will talk about different types of data operators when we get there. But to separate them at this stage, when we delete something, we can roll it back. So that means if it's possible for us to roll it back, there must be something such as a recycle bin that when we delete, it temporarily moves those files in there. So that means, since when we delete it, it has to go write it into that recycle bin or whatever file before it deletes from the original table, in this case Providence. That means it tends to be slow. If it's a million record, it has to write the whole million record into one place Once you finish writing it into one place, then you officially delete it from the table. Truncate, on the other hand, does not write anything anywhere. Once you truncate it, it is gone. It's like permanently deleting something. Since it doesn't need to be written into something such as a recycle bin, it is more quicker. It is more faster. In addition to it being a DDL. But I'm not focusing on DDL or DML, even though I've separated them in that area. But I just want us to understand the fundamental difference between the two. They both do the same thing, but one has one can be retrieved back in as much as the transaction has not been committed. The other one cannot be retrieved back, even though it did not commit it. Now, since the table has been truncated, I have to drop the table. Then now, you don't have to drop it necessarily, but because I already have my script in creating the stuff, which includes the creation of the table and inserting into it, I don't have the desire to edit it right now. That's where it's much more easier for me to drop it. That's why I just dropped it. Our next command that we like to learn is alter. 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 Now they have, like we said before, alter is used to add, delete, modify, or rename an existing table. What is he adding? What is he deleting? What is he renaming? What is he modifying? The first one we are going to tackle is add. Alter is used to change the integrity of the table. Update is used to populate or make changes to the data of the table, in the table. Update versus alter, remember that. Alter changes the structure of the table. Update changes the content of the table. Describe providence. Let's add a column. The column that we used the last time was gender. Alter table providence. Add, what are we adding? Gender. I will intentionally misspell gender. I want to spell gender, but intentionally I'm spelling Jenna, which is fine. What data will go inside this table called gender? We want a variable character. What is the maximum character that this column can hold? We want it to be 2. Semicolon, enter. Describe providence. Now we have a new column called Jenna. Oh, now I realize that, gosh, that wasn't what I wanted to do. I wanted to spell gender. I spelled Jenna. Let me delete this table, this column, sorry. Delete the column. That takes us to our next command. Alter table providence. Drop column Jenna. Describe providence. Now it is no longer there. Now let me redo what I'm supposed to do. I'm supposed to spell gender. I made a mistake. I spelled gender. Alter table providence. Add. This time I'll make a mistake again. Let me describe the table. Instead of me spelling gender right again, I fat fingered the keyboard. I did not put the E. That takes us to our next command, modify. 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 What are we modifying? We can modify the types of data that it holds. Modify the types of data that it holds. Now let's do that modify last. Let's do that modify last. Let's learn rename first. Rename. Since I spell it wrong, this is an opportunity for me to correct it or just stay away from gender, since I cannot seem to spell gender. We run the same command, alter table providence. This time, rename this stuff that we keep misspelling. We need to put column. Column gender to, this is an opportunity for me to spell it right. Or I can just say, you know what, I'm tired of misspelling it. Let me just write sex. That's even much shorter and I don't have to deal with it. Now the column has been renamed from gender to sex. Describe providence. Now gender is now sex. I could have renamed it and spelled it right. But now, gender has a variable character. That means it can only hold characters, A, B, C, D. But we want it to hold numbers. We want it to hold numbers instead of character. So for man, put 1. For female, put 2. For transgender, put 3. We run the same command, alter table providence. Now, because we are making changes to the data type, we say modify. What are we modifying? Sex. That's a column name. Number. We want it to hold 5. Describe providence. Now, instead of it being character, it is now number. $181.29. So we go. It is now number. That takes us to where we are today. Constraints. Constraints. So we have several types of constraint. Not null, unique, primary key, from foreign key. In this one, let's create a table. So Mr. Tola, you have been tapped to create a table for the shipping department. They want the name of the table to be shipping. They are now asking you, could you please tell us what do you need to create, or what are the columns that you will recommend in creating the table? So Mr. Tola has helped us with the creation of a table. We have the command that we use in creating table over here. But when we run this command, let's run it. Let's see some flaws with us creating a table like this. The table now exists. Describe shipping. Now this is shipping, and these are the columns. So we have created a table called shipping. In shipping, we have inserted 3 rows. We have populated the table. Select star from shipping. Now the 3 rows that we did have the same information. So if the table is not created right, there's a possibility for some repeated data. Then when your data is being repeated, it is not accurate. The information is not correct. So to fix this problem, there needs to be some integrity constraint in the creation of the table in of itself. We will drop this table since it wasn't done right. This is the command we use in creating the table. That takes us to our constraint. The first one, not null. What does that mean? We don't want the column to be empty. The column cannot be empty. So we put that restriction over there. We want this column to be populated. Have you ever tried to fill out a form online and they tell you it is mandatory for you to put something over there? You cannot leave it blank. In addition to that, that takes us to the next command, unique. We want this column to be unique. Or better yet, this column to be unique. We don't want it blank and we don't want it unique. Let's put it on a different row so we can see both. So now let's run this command. Describe shipping. Now we still maintain the same stuff that we did. Now let's run this command. Let's populate the table. We run it once. It creates the data. Let's save the transaction. Let's run that same command again. This time he said, no, you got a problem. You have violated a unique constraint. What is the problem with this? We already have a unique constraint on the driver name. That means no other driver should be called Tayo Akins, because there's a unique constraint on it. Let's leave this one blank. Again, you have violated another constraint. You cannot leave that stuff null. You need to put something in here. So instead of Tayo Akins, you can call it Akin. Then it will take it. Now, both of the rows are unique in nature. Truck number needs to have something. The driver name cannot be duplicated. There will be something that separates them. Is either you put a dash over here that makes it unique, that makes it stand out. So if we create another one and we put this one like this, it will create it. The number may be the same thing. It doesn't care about the number. That's not the stuff that you gave it. You did not say the number cannot be repeated. The number line, the truck number is not unique. What is unique is the driver name. So is it possible for you to now say, okay, I don't want it to be null. In addition to that, I don't want it to be unique. Yes. But the instruction that the way you created the table is that you don't care whether the numbers in the truck number in the truck number column are repeated or are duplicated. You don't care about that. What you care about is I want my driver name to be unique. Now that may not be the best business way of doing things, because you could have two people bearing the same name. On a normal circumstance, the best place to put it is probably the truck number, because the two trucks are different to begin with. We're trying to define index and view. And an index can be created on a table. What is it created for? So that it can be found more quickly and more efficiently. To make the querying of the table quicker. Example. There's a store called Walmart. Or let me use something else. There's an organization that they have a table that has a lot of columns. But they notice that the most command that they run is their first name and last name. They can index that column so that when they query it, it comes out quickly, instead of scanning the whole million rows to find out the data in it. In this case, we already know we have a table called shipping, or better, Providence. We have a table called Providence. Let's create index on the first name and last name. Create, what is the name that we want to call the index? Create index idx underscore Providence on Providence on the table. We want the index to be on the first name and the last name. Now when they query the first name and the last name of this table, the output, or it will be much more easier for them to find those stuff when it's being queried moving forward. It has been indexed. Now we have to be careful. Too much indexing on the table or in the database can cause some performance issues, and we'll talk about that later. The next one I want to talk about is a view. A view is a virtual table on a result of an SQL statement. On a result of a SQL statement. Let's continue on that view on Thursday. We like to do some examples extensively on that. So we are moving 4 things up to Thursday. Index, even though we've already created it, we will still move it to Thursday to elaborate on it. Views, foreign key, and primary key. Foreign key and primary key. But just to explain the primary key, a primary key is a combination of no, null, and unique. It ensures that a column in a table have a unique identity, which helps to identify that particular record in the table much more in a quick and efficient way. A foreign key, on the other hand, is a constraint on one table that references another value in another table. So that means a foreign key on table A will reference a primary key on table B. That's why they call it foreign key. It references another record in another table. It references a record in another table, I should say. Finally, on the data type, we have been using several data types. There are a lot of data types, but we are only focusing on 5. Varchar 2, date, time, number, timestamp. All this stuff, I believe by now, we already know what they do. So when we create a table, we said in this column, We want characters, variable characters. That's what we want the content of that column to be. Characters, obviously, as you know, is from A, B, C, D up to all the way to Z. Date, on the other hand, stores the month, the year, and the day value. Where did he get it from? Whatever you put in it, that's what it stores. But it stores it in year, month, and day, or day, month, and year. But it stores the year value. Number is the same thing. It's just a digit. You can actually use number, or you can use integer. That's another data type. Time, on the other hand, that stores the hour, minute, and second value. Hour, minute, and second value. Timestamp. It stores the value of date and time. Year, month, day, hour, minute, second. While we are still at it, let's go ahead and identify the 4 types of data operators. DDL, DML, DCL, and TCL. This is the task we will be doing in class today. I will define what they do. I expect each and every one of you to give me 2 examples of each. I will provide you with 1. I expect you to give me 2. At least this one we cannot get 2 each because it's not enough of command that is categorized under TCL. But the first one is called data definition language. It defines the data. An example of this is the command create. Anything that has to do with the structural integrity of a table, this command is used. DDL. The next one, data manipulation language. Anything that has to do in managing the data inside a table. All the commands fall under this, such as update, the third one is data control language. This one is used to give access or revoke access in the database. Example, grant. And the final one, transactional control language. This one is used to manage changes made to a data manipulation language. Changes made to this one, that is a TCL is used to manage it. An example of this will be commit. An example of this, I'm putting this over here so you can copy it if you want to. An example of this will be commit. We will go ahead and end the class over here officially. We will finalize our structured query language class on Thursday. Then Saturday we'll use it to review everything we have done so far. Then go into the architectural part of the database. Into the architectural part of the database. On Saturday we'll be running a lot of commands. Hopefully by Saturday I should have a temporary user. I'll give you access to the cloud database. Then I want you to just go ahead and play with it. So you're not going to be complaining that your database is slow, since that is a server. Well, I'll let you know if that's the case. If we can't do that, we'll do it on our computer, on our local client.